Hello everyone, myself Navyatha Ravi, working as Assistant Professor in MLR Institute of Technology. Today I am going to discuss about Introduction to Relational Model, and the overview of this presentation includes Introduction to Relational Model, Creating and Modifying Relations using SQL, Integrity Constraints over Relations. So let us discuss with the first concept, that is Introduction to Relational Model. So what is Relational Model? Till now, we have discussed about ER model, entity relationship model, which is used to represent a model in a diagrammatic format, and that diagram is called as ER diagram. What is the next step of that? We used to thought of one project, and that project must be put on some paper. That means the design of that project must be put on a paper. That design will be done by ER model. And what is the next process? So that will be done by using relational model. So to convert ER model into relations is nothing but a relational model. So what a relational model deals with? It deals with relations. Relations are nothing but a set of tables. That means if at all we used to insert a data into a database, that we are dealing with in a table format. The table consists of set of rows and columns. So why we are preferring this one? Because the insertion will be easy, the deletion will be easy, and the updation to such a particular element will be easy. Considering all these things, we used to represent a data in a table format. That will be dealt in this relational model. Next, creating and modifying relations using SQL. So we are going to deal with relations, right? How we can able to know how to create those relations? By using which language? By using SQL, structured query language. And the last one is integrity constraints over relations. That means after creating a relations or before creating a relations, we must follow some rules and regulations to violate the constraints, or else to violate whether any violations can occur. We used to restrict those violations. That is the reason we have to follow some constraints, the rules. So these are the topics that we used to discuss in today's session. So coming to the relational model. Relational model was proposed by E.F. Codd in 1970 at IBM to model the data in the form of relations or table. The data that we are going to store in the database in the form of tables. After designing the conceptual model, which we have discussed in the previous session, so designing the conceptual database. So after designing the conceptual model of a database using ER diagram, we need to convert the conceptual model into relational model. So after developing an ER diagram, the next step is to convert that ER diagram into relational model in the form of relations by using SQL. The relational model uses a collection of tables to represent both data and the relationships among those data. Each table has multiple columns and each column has unique name. For example, let us consider one table, that is nothing but student table, as we are taking the same example, right? Student table, because of our convenience. And this student table contains student ID, student name and student address. So each table has multiple columns. We have multiple columns and each column has unique name. We have each and every column has unique name. So in this format, we used to first create a table. Tables are also known as relations. These tables are also called as what? Relations. Tables are also called as relations. So here I used to consider what? Student table. So it can also be called as student relation. The relational model is an example of record based model. Why? Because we are storing the records here. That means we are storing some data, and each and every row is called as a tuple, and those data is called as a record. So it is an example of record based model. So the relational model represents how data is stored in relational databases. That means a relational database consists of collection of tables, each of which is assigned a unique name. So, each table has separate unique name. For example, let us consider this table. This table name is nothing but student table. The name of this table is nothing but student, which contains 5 attributes or 5 fields. So, these are nothing but what we call as, each and every field is called as an attribute or field or column. So, here we have 5 columns in a particular table, and those 5 columns are also called as attributes or fields. So, here each and how many rows are there? We have 4 rows. This is one row, this is another row, 2, 3, 4. We have 4 rows here. Each and every row is called as what? Each and every row is called as tuple. Here the row is called as tuple. So, here we have 4 tuples or 4 rows. A table consists of tuples and fields, or else a table consists of attributes or rows. So, consider a relation student with attributes roll number, name, address, phone number and age as shown in the below figure. So, some of the important terminologies that we used to know about the relational models. Why? Because we used to store the data in a form of tables. So, we used to know some of the terminologies here. What is attribute? Attributes are nothing but the properties that define an entity. So, in a particular table, as I said, roll number is one attribute, name is some another attribute. Here the column names are called as what? The attributes. Okay. What is relational schema? Relation schema defines the structure of a relation and represents the name of a relation with its attributes. So, for example, here what is the schema? Schema is nothing but the design, the basic design. What we are designing here? Student table. So, what is relation schema? Which is nothing but the name of that design, that is nothing but student. And what are the contents present in that design? What are the contents here? Roll number, name, address and phone number, right? So, this is what we call as relation schema, the design. Next, what is a tuple? Each row in a relation is known as tuple. The above relation contains 4 tuples. Each and every row is called as tuple. And the above relation means in the previous slide, see here, each and every row, this is one tuple, this is another tuple, this is another tuple, this is another tuple. We have 4 tuples, and please observe, each and every row is contained with some data except the last row, 4th row. So, why? Because this is what we call as null. That means it doesn't define any value here, no value has been defined, that is called as null value, right? And the next thing is, what about relational instance? Set of tuples of a relation at a particular instance of time is called as relational instance. That means how many number of tuples at this particular moment is nothing but relational instance. That means till now we have 4. Till now we have 4 tuples. For example, now I have added one more record, one more tuple, that means 5, some ABC, Hyderabad, some 924824 and age is nothing but 19. I have added. Now, what is instance? What is now my relational instance? It will be 5. It will be 5. Why? Because I have added one more record. So, relational instance means the number of tuples it will return at that particular moment of time. Previously, it was 4 and now it became 5. That is the difference. Next, what is degree or arity? The number of attributes in a relation is known as degree of that relation. For example, if a table contains number of columns 3 columns, just like roll number, name and address. What is the degree of this table? It is nothing but 3, right? So, this is the degree is also called as arity here, arity. The number of attributes in a relation is known as degree of that relation. The student relation defined above has degree 5. Why? Because in the previous example, we have 5 attributes. That's why the degree will be 5. What is cardinality? The number of tuples. Tuples means nothing but here rows. How many rows are there? In the previous table, we have 4 rows. So, what is cardinality? The number of tuples. The number of tuples in a relation is called as cardinality. Here, the student relation defined above has the number 4. Why? Because we have 4 rows. Next, what are the null values? So, the value which is not known or unavailable is called as null value. As I have already said in the previous example. So, in the 4th row, we doesn't have any value, right? So, that is nothing but a null value. That means we can't define that one. And one more thing here you have to remember, 0 is not a null value. 0 comes under a particular value, right? So, 0 is different from null value. We are assigning a value 0, but null value is nothing but we can't able to assign any value. That is nothing but null value. 0 is absolutely different from null value. 0 also comes under a particular value, right? So, the value which is not known or unavailable is called as null value. It is represented by blank space, right? Let us see an example which I have discussed here. So, here this is what we call as, this is nothing but a null value which I can't able to define. It will be represented by blank space. So, these are some of the important terminologies that we used to know about our relational model. Next, creating and modifying relations using SQL. So, how we have to create a relation? How we have to create a table? By using SQL language, structured query language. So, to create, we use DDL commands. And in previous sessions, we already discussed about database languages. What are the database languages? We have 4. We have discussed 4: DDL, DML, data control language, TCL, and TCL, transaction control language. So, here DDL. DDL contains how many commands here? Create, alter, rename, truncate, drop. These are the 5 commands comes under DDL. By using only these commands, we can able to create a particular table, right, or a relation by using DDL. First of all, to insert the records into the table, we have to create the table. That means we have to construct a design. That is what we call as, that can be done by using data definition language commands, by using create command especially. What is DML? DML command, after creating the structure, we used to insert or update or delete into the table. That will be done by using DML commands. DML commands comes under what? Select, insert, update, and delete. These are some of the commands under DML, data manipulation language. That means we used to manipulate or we used to update the data. So, without the creation, how we can able to update? That's why our primary job is to create the database, create the structure of a data, right? So, here next, the third one is data control language. We used to control some unauthorized access. That will be done by using DBA, database administrator. So, here he used to give permissions, for example, grant, revoke. These are some of the commands comes under DCL, data control language. That means to control the unauthorized access of data, DBA must grant and revoke the permissions to a particular user, set of users. Transaction control language. Transaction control language consists of some of the commands like commit, rollback. As we have discussed these things earlierly in previous slides also, commit, rollback, and save point. Just for revision purpose, I am again discussing these things. So, transaction control language which have the commands commit, rollback, save point. Commit means if at all we used to permanently change, we have permanently save the data in a database, then we use commit command. rollback. If at all we used to roll back, just like Control Z, we use rollback command, and save point. From that, we used to set a particular point. From that point, we used to roll back. Then it can be, that particular point can be represented with the save point. So these are some of the commands that we use to create or update a SQL query, right? So by using DDL commands to create, modify relations in a SQL. So to create a student relation means to create a student table. So what we have to represent, how we have to represent in SQL. Create table, this is what we called as table name. Create table, table name with attributes. So what are the attributes that I am going to create with this table? SID, and here what is the data type of this one? Integer. SID integer, and name of character type, and address of variable varchar. The difference between character and varchar is about the fixed size, fixed length. Here in character is of fixed length. That means 20 bytes will be allocated. Whether you use or you may not use all the 20 bytes will be allocated. In varchar of 20 bytes will be allocated, but if at all use only 10 bytes, and that 10 bytes will be again reusable. That is what the basic difference between character and varchar. So character comes under fixed length, varchar variable character which can be changed, right? And here to create a particular table, to create a particular relation, first of all we need to write create table, table name. That is what the table name is, nothing but student. Create table, table name, and this contains attributes SID, name, address, SID, name, address, phone number, and so on, age, phone number, age. So this is the table that I have to create. To create this structure, I used to represent in this format by using SQL language. So whatever the attributes that you are going to represent, so beside those attributes, you have to represent the data type of that particular attribute, So for character, for varchar, you have to represent the size also, how much size that you want to allocate for that particular attribute. So to insert tuples, that means rows. This is only for creating the structure. Here I didn't insert any kind of data. To insert a particular kind of data, first of all we need to create, right? So that is the thing, that is the job will be done by using DDL. DDL is for creation. DML is for manipulation. Manipulation means inserting, updating, like that, right? So to insert rows into a table, we use insert command. Why? Because after creation I have to insert a row, right? So by using insert command, we used to insert those elements. So what is that command? Insert into table name. Insert into table name. This is what we called as table name. Student is the table name, right? So insert into which table? The table name you have to mention here. Insert into table name, for which attributes that you have to enter the values, and you have to open the brackets and you have to mention all the attributes in the table. So SID, name, address, phone number, age, in a sequential manner. Whatever the order that you have mentioned here, the same order must be followed here also. The same order must be followed while entering the values, right? So please don't forget this point. Whatever the order that you have mentioned here, the same order must be mentioned while representing the values. So the above statement, this statement can also be represented in a shortcut manner, that is nothing but insert into table name by using values. Here we have represented each and every column separately, and for each and every column we have represented the values here, in a respective manner, right? So without representing all these column names, we can able to represent the same query in this manner also, without representing this column name specially. So insert into table name values, and we can give directly values which are you are going to insert. So now the table can be created with some values, right? So, for example, what is the first one? SID, name, address, phone number and age. So, these are the columns. So, what is the first row that you are going to insert? 1, SID will be 1, name. Name is nothing but set of characters, right? So, you have to represent it in single quotes. That's why I have represented here the name in quotations. Why? Because it is set of characters. So, address is also set of characters. That's why you have to represent it in single quotes. For example, hide. Next, for example, phone number. It is an integer. You can directly represent in a form of integers, numbers type, right? Next, last one is age. So, age will be inserted. If at all you have to insert another row. So, what will be the command that you have to write? So, insert into table name, that is nothing but student. Values, what are the values that you are going to insert? Insert into table name, values. For example, I have to insert to XYZ like that. So, here the same command will be run and change the values to XYZ, Telangana and the number 9678423251 like that, comma 15. This is the second row. The same command must be written here with the values that you are going to insert. So, in this manner we used to insert the values in a particular table. First of all, to insert values to a particular table, we have to create the table by using DDL command, that is nothing but create command. Later on, you have to insert a particular values to a particular table by using insert command. Next, third one, we can able to delete a particular row, right? So, we can delete the tuples using delete command. So, how we can able to delete? By using this structure, delete command. Delete from which table you have to delete? From student table. Delete from student. Here I am declaring one more variable to access that particular data in a particular table. To access, just like a pointer. A pointer points to a particular address location, right? In that manner, I used to declare one variable to pick a particular point, particular data from that table. So, delete from student S, where S dot name is equal to ABC. So, here I used to delete a particular data where name is equal to ABC. So, from student table, I used to delete a name ABC, that will be deleted. So, in this manner, we used to delete a particular row from a given table. Next, we can modify the column values in an existing row using the update command. So, already if at all I used to have a table with the values, for example, name, SID and age. Name XYZ, SID 1, age 10, ABC, SID 2, 20. So, here what I have to update my age for SID is equal to 1. I have to, that is my query. I have to update my age for SID is equal to 1. Then how I can able to update? By using update command. So, how? Update what? Update this particular table. What is that particular table name? Student table, right? Update student table. Here I have created one variable, yes, to retrieve a particular location on the table. So, update student, yes. Set, what I have to update? This age, already existing age plus 1, or else just I have taken an example to update. You can take any other formula or else anything. Set S dot age is equal to S dot age plus 1. That means the current existing age will be incremented by 1. That is the problem here, right? So, set S dot age is equal to S dot age plus 1, where SID is equal to 1. Here SID is equal to 1. I have to increment the age here plus 1. Now, the age will become what? 11. Clear? So, if at all I used to update the values in an already existing table then we can able to do that by using update command, right? This is one of the examples.